When we're solving the equations, we solve the equations based on whether the ratio is positive or negative to know where the rotation angle would exist. And then based on the parameters, in this case, just looking for the possibilities between 0 and 360, if I know the ratio is positive, there's going to be 2 quadrants that can end in there. So using that reference angle, I can figure out what the rotation angles would be. Now remember, when you use your calculator to do this, it's only going to tell you what the reference angle is. So if it said that sine of theta was 0.5, then theta, and I know this is going to be my reference angle in here, is going to be sine to the negative 1 of 0.5, which is equal to 30 degrees. Then the next part is, where is sine positive? Because it says that ratio is positive. Sine is positive using my cast rule in quadrant 1 and in quadrant 2. In quadrant 1, my angle is going to be the same as my reference angle, or 30 degrees. In quadrant 2, my angle is 180 minus my reference angle, or 150 degrees. And the nice thing is, I can put both of these back into my calculator and say sine of 30 or sine of 150 and check to see if I get 0.5 or 1 over 2 for both of them, which I 100% do, which means that the angle is either 30 degrees or 150 degrees. Because there's 2 quadrants where sine is positive, there's 2 answers where this works. When I'm going to do it for sine of x is equal to negative 0.8090. First thing, I'm going to solve my reference angle. My reference angle is going to be sine to the negative 1 of the positive value of this ratio. We always take it from the positive value because that can skew our results. Our reference angle is going to be approximately 54 degrees to the nearest degree. Now it says that my ratio is negative. Where is a ratio negative? In quadrant 3 and in quadrant 4. Because it's saying that my angle is represented by x, I'm going to say that x in quadrant 3 would be 180 plus my reference angle, which is 234 degrees. In quadrant 4, it's going to be 360 minus my reference angle, or 306 degrees. And then I can just state that x is equal to 234 degrees, or 306 degrees. do the same thing where it's taking it from cos. My reference angle is going to be cos to the -1 of 0.8090. My reference angle in this case is going to be 36 degrees. Where is cos negative in quadrant 2? And in quadrant 3. In quadrant 2, I can say that x is equal to 180 minus 36, or x is equal to 144 degrees. In quadrant 3, x is equal to 180 plus 36, or 216 degrees. X is either going to be 144 or 216 degrees. For the last one, my reference angle is going to be tan to the -1 of positive 2.4586. So my reference angle is going to equal, in this case, approximately 68 degrees. When is tan negative? In quadrant 2 and in quadrant 4. So in quadrant 2, x would equal 180 minus 68, which is going to give me 112 degrees. In quadrant 4, x would equal 360 minus 68, which is going to give me 292 degrees. X is equal to 112 degrees or 292 degrees. We have some other interesting possibilities where if I say sine of theta is equal to 1, well, that gets a little trickier because when I solve my reference angle, I get 90 degrees. Well, what's that going to look like? If sine is positive here and here, then that means that my reference angle would come through here or here. But if I do 90 degrees from 0 degrees or 90 degrees from 180 degrees, then this actually only has one possibility. It's going to be in between quadrants 1 and 2, because if I took quadrant 1, it would be 90 degrees. If I took quadrant 2, it would be 180 minus 90 degrees. And no matter what, theta equals exactly 90 degrees. For example B, if I take cos of 0 degrees, then my reference angle is equal to cos to the negative 1 of 0, which is also 90 degrees. But 1 is actually a positive number. Positive 0 and negative 0 are the same thing. So this gets even more confusing, because now, if positive and negative 0 are the same thing, I can take the positive cos regions, or I can take the negative cos regions. And this actually pulls from all 4 quadrants. But if I have a reference angle of 90 degrees, 0 plus 90, or 180 minus 90, is 90 degrees. But down here, 180 plus 90, or 360 minus 90, going from quadrant 3 or quadrant 4, are both 270 degrees. Which means that my angle for this one is either 90 degrees or 270 degrees. Because 0 exists between positive and negative numbers, so it actually fits into all 4 quadrants. Sometimes you'll get questions where it doesn't even have it isolated, and we need to isolate the value. So think of tan theta like it was x. If I had 3x plus 1 is equal to 4, all I would do is I would subtract 1 from both sides and divide both sides by 3. Well, it works the same way here. If I have 3 tan theta plus 1 is equal to 4, I'm going to subtract 1 from each side. And I'm going to divide both sides by 3. And in this case, my reference angle is tan to the negative 1 of 1, which is 45 degrees. Now we know that tan is positive 1 in quadrants 1 and 3, but here it restricted the possible values to being between 0 and 180, and because quadrant 3 is above 180 degrees, we can't include quadrant 3. The only place where it's positive for tan between 0 and 180 is literally just in quadrant 1. So my angle is equal to my reference angle, 45 degrees. And that's my only solution. All right, go ahead and get some practice.